This is Dr. Ryan Johnson with Introduction to Statistics for Grace College. We're doing section 4.4 today. So this is our last section involving confidence intervals, and it's looking at the factors that affect the width of the confidence interval. So you should have read section 4.4, which has to do with cat owners and things involving cats, like spending on cats. I think something to really pay attention to is the example of the Minnesota versus all US of the same poll, where because the sample size for Minnesota was smaller, there's a larger sample size there. And then the graph of there, and some good examples of calculation. Okay, and it's a very good caution at the end for this as well. So let's move on to the worksheet then. So for the worksheet, we're going to look at a result from a Gallup poll from 2019. It asked 1,526 U.S. adults how much they plan to personally spend on Christmas gifts this year. So the reported average was $942. So identify the observational units and the variable in the study. Classify the variable as quantitative or categorical. Okay, so let's review. Define the parameter of interest in the study. A good way to, good thing to think about before you just define the parameter of interest is this a mean or is it a proportion? And for what population? Okay, number 3. Which two of these 3 quantities do you know? What's simple? So first, let's back up. Because their variable of interest, dollar amount intended to spend, is quantitative, the parameter of interest here is the population mean for all adult Americans. Call this mu. To construct a confidence interval for mu, we need to know the sample size, the sample mean, and the sample standard deviation. Which two of these 3 quantities do you know? What symbols can be used to represent them? Okay, so number 4. What we are not told by Gallup is S, the sample standard deviation. Explain in your own words what S represents in this context. Okay, now number 5, suppose S was equal to 150. Use a 2 standard deviation method to approximate and interpret a 95% confidence interval for mu. So use a theory-based approach for the confidence interval for mu. And then remember that formula from last section. Okay, suppose S was equal to 300. Use the 2 standard deviation method to approximate the 95% confidence interval for mu. How does the interval compare to the interval from number 5? So is the midpoint the same or different? Is the width the same or different? Explain why the changes you observe make intuitive sense. Like, what's intuitive is another word for like common sense. Okay, so why does it make common sense? Okay, now let's look at the impact of sample size. The poll involved 751 men and 775 women. Suppose we looked at only one of those subgroups. How do you expect the width of the intervals to compare to the interval based on the total sample? So again, like think about the Minnesota United States thing from the reading for that one. Okay, feel free to mention that in your explanation. Suppose the women reported planning to spend an average of 942 with standard deviation 150. Compare the margin of error of this interval to that of question 5. Was your prediction correct? So now, given your common sense and what you learned from the reading, actually do the computation and compare. Okay, so number 9. In general, how does the width of a confidence interval change as the sample size increases? Why? Okay, so use some good explanation there. Okay, moving on to here. So we've got our key idea, which lists out the width of a confidence interval for population mean mu decreases. So here are the things that make the width of the interval decrease. If the confidence level decreases, so if you're okay with less confidence, your interval can decrease. If the sample size increases, then the width of your confidence decreases because you're going to be more certain. And as the standard deviation decreases, So if the standard deviation decreases, then you're also more certain, so your width decreases. Okay, so here we have, if you wanted to answer the question, do U.S. adults spend significantly less than $950 on average for Christmas gifts? A confidence interval can answer the question. If we look at the confidence interval that was constructed, assuming the standard deviation of spending to be 150, we get a confidence interval entirely below 950. So yes, on average, U.S. adults are spending significantly less than $950 on Christmas gifts. While this may be statistically significant finding against the average, it doesn't mean that the average amount is far less than 950. The upper end of the confidence interval is 940, 953. So you're only 47 cents away. So the margin of error is the interval is about $7, arguably less than should be spent on one additional gift. So that kind of goes to our next key idea. Especially with large sample sizes, even a fairly small difference between observed and hypothesized value can be significant. In such cases, the confidence interval for the parameter can help to decide whether the difference is large. Okay, so here we've got more information from the Gallup poll. You might need to kind of go over there. Maybe I just there we fit it all in there. Okay, so number 10. Based on this information, what appears to be the more reasonable guess, 150 or 300 for the sample standard deviation? Explain your reasoning. Okay, so for this one, I want you to think about how when data is bell-shaped and normal, then only 5% of the data is 2 standard deviations away or more. And so if you look at your average around, it's kind of at the upper end of the 900, then if your standard deviation is 150, then 2 standard deviations is 300. So how does, is there roughly 5% of the data outside of that? Or if your standard deviation is 300, then two of those is 600. So is roughly 5% of your data outside of that. It's hard to tell, but that idea of 5% of the data being roughly outside of 2 standard deviations should be the thing that you use for number 10. For number 11, based on this information, do you think the theory-based inference method is valid for these data? Do you think the sample data are roughly symmetric? What is the sample size? So, remember the validity condition from last section. The validity condition, you can look that up in your last worksheet or in the reading from last section. And then use that validity condition and look at this. And you don't have all perfect information, but you have enough to make a good guess here. Okay, and that completes this section.